Alright guys, this is our second lesson of Unit 6, which is on exponents. We're going to be talking about zero and negative exponents. And you pretty much could do this whole lesson because of what we talked about last class. So this is just going to reiterate some of the things we discussed. It's going to be kind of weird to think about why you might have 2 to the 0 power or 2 to the negative 4, and we'll explain how you get these and what they mean in this lesson. So on exercise number 1, part A, he wants you to go ahead and fill out this different table to kind of show you what 2 to the 0 means. So we already discussed what it means, but see if this will help you out. So we knew it was 1, but why is it 1 like that? So take your time and fill these in. So hit pause and do that now. All right, if you looked at the relationship, they were multiplying 2 to the first power is 1 times 2 and equals 2. 2 to the second power, 1 times 2 is 4. So if we use that relationship, you could see that you should have got something like that, and you should have got something like that. And you can see what happens is we're just taking a 2 off each time. So if we took a 2 off here, we would be left with a 1, so 2 to the 0 would be 1. So that's one way you could kind of think about why 2 to the 0 is 1. Another way that I typically use, if you think about this problem here, what would this equal? 2 to the second divided by 2 to the second. Well, you guys would know that that's really 4 divided by 4, which also equals 1. So you guys should know how to do that. It's pretty easy. And if you remember the exponent rules that we talked about dividing, if I use those, then what I really would have done is take my exponents and subtracted them, which would have equaled 2 to the 0 power. Now remember that this thing is the same as this, so whatever answer I got for here, I should get the same answer for this one. So this came out to be 1, so therefore this obviously has to equal 1. So this is another way of showing you why anything to the 0 power equals 1, because if you have a 0 exponent, that means you must have the exact same top and bottom of the fraction. You're dividing the same numbers because you have the same exponents. That's how you got 0. Alright, for part B, it's saying if positive exponents indicate multiplying numbers repeatedly, then negative exponents should indicate dividing repeatedly. So you can see what he did here. He's saying 2 to the negative 1, instead of multiplying by 2, you're dividing by 1, 2. 2 to the negative 2 means you're dividing by 2 negatives, which we know now looks like this, and you get 1 to the 4th. So with the same pattern in mind, 2 to the negative 3rd means you're dividing by 2 3 times. This would be 1 over 2 to the 3rd power, and therefore you'd end up getting 1 over 8. And same pattern here. One thing I want to talk about really quick, depending on what the question asks, you have to know how they want you to write it. This form is called exponential form when you have your answer with an exponent. This would be if it says simplify or evaluate all the way. This is also referred to as standard form. So this is exponential form, this is standard form, and it's important you understand what the question, the question asks you to express the answer. Now, another way you could think of why negative exponents make fractions, I have another scenario for you. So if I did 2 to the second divided by 2 to the 5th, you should know that 2 to the second means 2 times 2, and 2 to the 5th means there's 5, like that. And when we divide, we know that if I did 2 divided by 2, that would just get 1. 2 divided by 2, that would just get by 1. And on the top, I'd have 1 times 1, and just end up getting 1 at the top. Oh, sorry. There we go. And on the bottom, I have 2 times 2 times 2, which is 2 to the 3rd power, so I'd end up with that. And now, if we used our division x power, where we know to subtract those, then I would just do 2 minus 5, which ends up to be 2 to the negative 3rd. So remember, these are exactly the same. So whatever this answer is, I should get the same answer for this one. So therefore, this 2 to the negative 3rd has to equal that. So that's another way of thinking why the negative exponent makes a fraction, because what it's saying is that there's more powers on the bottom. You're subtracting by a bigger number. So you're doing a small number minus a big number, so the leftovers must be on the bottom. Hopefully that makes a little sense. All right, so let's keep moving on with these. So we have these powers on our sheet, so now we know anything to the 0 power is 1, and we know a negative exponent pretty much makes the fraction, and the exponent becomes positive. So questions 2 and 3 should be pretty easy. So hit pause and try to answer 2 and 3 and see how you do that. All right, for number 2, we had x to the negative second, which we know means 5 to the second, which would be 1 over 25. If you put that in your calculator, you're actually going to get 0.04. So the one that doesn't belong is obviously this one, because some of you guys still think 5 to the second means 5 times 2. That's not what it means. So this was the right answer. All right, for number 3, hopefully you did some work. Obviously, you know I like to do lots of work. So I plugged in my input value there, and then I know that this means 1 over 2 to the second, which is the same thing as 1 over the fourth. So I did some work in my head right there. And then this 2 to the 0 power means 2 times 1. So then I just kept going. So 3 times a fourth. And then therefore our answer was 2 3/4. So if you got that, nice job, which I believe is that one there. All right, so let's keep going. Hit pause if I'm going too fast. Okay, we've already covered these exponent laws, so there's definitely some more you should get. When you're multiplying, remember we just add the exponents, and we're taking the power to another power. That's when we multiply the exponents. So you definitely need to get those down. I'm going to skip all this, what we want to do. We've already done this, so this should be kind of obvious. When we're dividing exponents, then we know we should subtract those now. I should say dividing numbers, we're subtracting the exponents. So this would be really easy. We just subtract these and end up with x to the third. We'd subtract these, and we'd end up with 3 to the 5th power. Now see how it says exponential form? That means we could leave it like that. We don't have to figure out 3 times 3 times 3 5 times. And over here, again, we subtract these, and we simply get x to the 6th. So hopefully that's easy for you. Understand the rule. All right, so again, since we've already kind of did this stuff, I'm not going to have you like kind of do all this craziness. This should be easy here. First of all, you should be able to do this right away. Anything divided by itself, you know, should be 1. So that should be obvious. But why does that work? Because if we did our exponent rule and did 4 minus 4, we would get 2 to the 0 power. We know that 2 to the 0 equals 1. So another reason to show you how these all relate. Do our subtraction here. We get x to the negative 5, and therefore we get x to the negative 5 we know turns into a fraction, and there we go. Now what I would like you to do is start thinking of these ones and stop doing so much math. I want you to think of it more like this. So I have x to the second over x to the 7th. See, there's 7 of them, and you should understand that when we divide, these are going to cancel out. So there's more left over on the bottom. So that's why we get x to the 5th on the bottom here, and on the top is just 1, because remember, anything divided by itself is 1. So on the top it's 1 times 1, which ends up that. So when you look at this, just say, look, there's more x's on the bottom. 2 of these x's are going to get rid of 2 of those x's, and there's going to be 5 left down here. And you could avoid a lot of math and just look at that and know the answer right away. So if we look at this one, there's 10 5s on the bottom, 6 5s on the top. 6 of these are going to get rid of 6 of those, and you're going to have 4 5s left down on the bottom of the fraction. So that's a quick way of thinking how to do those. And it didn't say which form, so I don't know if we want 1 over 5 to the 4th or multiply it all out, in which you would get 625. All right, we're getting near the end here. And again, pause it, rewind if I'm going too fast. You should be able to do exercise 6 all on your own. So your plug, here's the function, the f function. You got a couple different input values, and don't use your calculator. You should be able to do these fairly easy using the exponent rules. It will save you a lot of time. So try that now, please. All right, and let's see how you did with these. So I got 16 for the first one, because 2 to the 0 is 1, so it's really just 16 times 1. Part B, I got 64, because I put in 2 here. This would be 2 squared, which is 4, and now 16 times 4 is 64. And now we're inputting negative 2, so we're taking 16 to the negative 2, which remember means this dropped to the bottom, so we're dividing by 2 2s, or dividing by 2 times 2, which is 4, and therefore your final answer is 4. So hopefully that went okay for you. We'll do some more exponent rules in class, and hopefully you'll feel better with them after 2 lessons.